Hi students, let us learn today applications of determinant and matrices. So how to solve a system of linear equations using inverse of a matrix. Let us consider a system of equation. In general, let us take it a1x plus b1y plus c1z is equal to d1. Next equation, a2x plus b2y plus c2z is equal to d2. And the third equation, a3x plus b3y plus c3z is equal to d3. For solving these equations, we will take matrices. Let A equal to a1, b1, c1, a2, b2, c2, a3, b3, c3. This is a matrix with coefficient of x, y, and z. And another matrix will be X, which is the variables X, Y, Z. And then we will have the matrix B, which is your D1, D2, D3. Okay. Now this particular system of equations can be written as AX is equal to B. That is, we will have this A matrix here, which A1, B1, C1, A2, B2, C2, A3, B3, C3, and then the X matrix X, Y, Z equal to B, which is D1, D2, D3. Okay, this is your matrix AX is equal to B. Now, how to solve this is we will take this as AX is equal to B, pre-multiplying by A inverse. It will be A inverse AX is equal to A inverse B, and then you can take this as A inverse A into X is equal to A inverse B. A inverse A is identity matrix, so IX is equal to A inverse B, and I into X is X, so X is equal to A inverse B. So you can find the solution of this variables X, Y, Z by taking the inverse and multiplying with the matrix B. Now, here we have some different cases, and we need to examine the consistency of the system of equations. So what do you mean actually by the consistent system? The system of equations will be consistent if its solution, it can be one or more, exists. If the solution exists for the system of given system of equations, then we call it as consistent system. And what do you mean by inconsistent system? Is if its solution does not exist. Simple. Now, how to check whether the given system of equation is consistent or not? Now we have seen here the solution is found by matrix method like this: X is equal to A inverse into B. When I say A inverse into B, so definitely the determinant A should not be 0, then only A inverse exists. So we have here the first case, you can call it as X is equal to A inverse into B if A is a non-singular matrix. Means what? Non-singular means what? That is determinant A not equal to 0. When the determinant A is not 0, then we call it as non-singular matrix. So if non-singular matrix, then only its A inverse exists. So if A is non-singular, its inverse exists, and we get a solution X is equal to A inverse B, A inverse into B. So in this case, the matrix equation provides a unique solution for the given system of equations. Means the system is consistent because we are getting a solution and we are getting a unique solution. So first thing, you can check whether the A matrix, determinant of A matrix is 0 or not. If it is not 0, then the system is consistent because we are getting a unique solution because A inverse exists. Now suppose next thing is, if A is a singular matrix, means what? Your determinant A will be 0. So when the determinant A is 0, we don't know whether it is consistent or inconsistent. So in that case, we have to do another check. We need to calculate, we have to calculate adjoint A into B. We have to calculate. And then in this case, we can check if adjoint A into B is not equal to a 0 matrix, not equal to 0 matrix, then solution does not exist. And if solution does not exist, then we say that the system of equations is inconsistent. So if it is not equal to 0, no solution does not exist, system is inconsistent. So next option will be adjoint A into B is equal to 0. In this case, the system may be either consistent or inconsistent according as the system have either infinitely many solutions or no solution. So there are two things. If adjoint A into B is equal to 0, then it can be either consistent or inconsistent. Depends on whether it has got no solution, means inconsistent, or it has got infinitely many solutions, means then it is consistent. Earlier in the definition, I told you consistent means the system of equation can have either one solution or it can have many solutions. In both the cases, the system will be consistent, whether unique solution or infinitely many solution. And then inconsistent means no solution. The way how to check it, I'm just repeating once again. You have to check the determinant A. If it is not equal to 0, means inverse exists, so we have unique solution, so the system is consistent. If determinant A is 0, then we have to check adjoint A to B. If adjoint A into B is not equal to 0, then straight away you can say that solution does not exist and the system of equation is inconsistent. If it is 0, then it can be either consistent or inconsistent, whether it has depends on whether it has got no solution or infinitely many solutions. So based on this, in my next video, we will proceed with the solving of exercise 4.6 questions. Thank you.